I have the pleasure to introduce José Barat. José Barat is a full professor of food technology at the Universidad Politécnica de Valencia. He's also a member of the SET panel and is actively working on food enzyme and on novel foods. Please, Jose, the floor is yours.
Thank you, Pier Sandro. Yes, first of all, I want to thank the invitation to participate in this summer school. And I hope at the end of my presentation you will have an overall idea of nanomaterials related with innovation and also with its regulatory aspects and safety evaluation. So I think now I don't have the control of the presentation because it's not in the presentation mode, no? Yes, now I have the control and yes, view, no, the full screen. Yes, I'm looking for the, okay, it's here. It's because it's very small in my computer. Okay, perfect. So just my presentation will have different sections. I have quite a lot of slices, so probably I won't be able to give a detailed description of all of them, but in any case, you have the presentation and links to interesting documents, and so you can follow it when this presentation finish and you have it for your own records. So first, I'm going to give an overall idea of nanotechnology. Here you have what is known as nanotechnology, which involves the control of matter at the atomic and molecular scale, which is normally considered to be below 100 nanometers. And what's the special thing with nanotechnology and why we are talking about it? It's because, in fact, that's the interesting thing of nanomaterials, and is that they exhibit different physical and chemical properties compared with the same substances at the normal scale. And as a consequence of that, there are very interesting new applications of these nanomaterials. But the fact that the behavior is different from the substance at the normal scale, there are some concerns regarding safety, in fact. Just to know, the first concern is that they have a high reactivity because they have a very high surface volume ratio. So the reactivity is very high for those particles. And the other one is, as you might understand, the size is very small, which means that they are capable to cross different protective, let's say, membranes that we have. They can cross the skin, they can cross the intestinal tract, so they can go to the blood, and finally they can end up inside cells, and they can accumulate in the body. So it means that there are some concerns regarding the safety of the nanomaterials. And I also wanted to give you let's say, an idea or some ideas. First of all, is that the use of nanotechnology in the food industry is quite, let's say, it's not an easy task. The first of all is because producing nanoparticles on purpose usually is very expensive, which means that only can be applied because of the, let's say, possibility, because of the cost of the technology in very specific applications. And the other aspect is that the regulatory frame regarding nanomaterial is quite complex, as I will explain you during the presentation. But to complement my previous slide is just to say that nanomaterials are everywhere. We are surrounded by nanomaterials, which comes from the nature. So it means that we have been surrounded for the whole history of human being. And we are also surrounded by nanomaterials that are produced by the activity of humans without any intention of producing these nanomaterials. In fact, here you can see we have nanomaterials coming from the sea in form of salts, from the volcanic ash, from the dust, the sun, the sand. All of them come from natural sources. So it means this has a positive message, is that we have been in contact with nanomaterials for a very long time. So it means that our body it has some mechanisms to protect us from our contact with nanomaterials. But we have also contact with nanomaterials. For instance, here you can see coming from sterling silver forks. You see that there are just some silver nanoparticles present on the surface of the forks, which means that we have been eating nano silver from a very long time. And here you can see the dynamics of nanomaterials in nature. Just to say that there is another good news dealing with nanomaterials, and it's that since they are very reactive, the tendency to form aggregates or agglomerates is very important, because they usually have some interactions among the particles and even among organic molecules that form what is called the corona effect on the surface of the nanomaterials. And here you can see, when we think about nanomaterials, we usually think about materials that are produced on purpose by human beings, but the production of different materials by humans has as a consequence the production of a small fraction of nanomaterials. In fact, here you can see two additives, the silica and the titanium dioxide, which contain or may contain, but in most of the cases contain a nanofraction of particles as a consequence of the production process, not because it's done on purpose, but because it's a consequence of the milling, for instance, the milling process, that a small fraction of nanomaterial appear. In fact, another source of nanomaterials, for instance, are the fabrics. When we are washing the fabrics, nanofibers are released from our clothes. So this is just to make you aware that in reality we have been and we are surrounded by nanomaterials in nature and in our daily activities. Well, as indicated in the title, nanomaterials are included in what are called regulated products, which means that these products require a scientific assessment to evaluate their safety before risk managers can authorize them for the European Union market. There are different type of products that are considered to be regulated, and nanomaterials are among them. So when dealing with the regulation, a very important thing is just to define what we consider to be a nanomaterial. And I'm going to introduce you and explain you which is the definition that is used by the European Union, which in the end is, let's say, is a consensus. But obviously there are some different possibilities and concerns. In fact, there was a first definition adopted in 2011. And in June this year, a new definition has been released, or a new suggestion for definition in the European Union. Here in this slide, you can see which has been the adopted recommendation, which was approved this summer. And it's that a nanomaterial means a natural, incidental, or manufactured material. So you see Here you have all the possibilities. We have the ones that are present in nature, but also which are produced incidentally, as I mentioned to you, for instance, producing silica, amorphous silica, which is sold as an additive and used in the food industry, but also which is manufactured on purpose. So in fact, I will give a short explanation of different potential application of nanomaterials in the food industry. They consist of solid particles, solid, which are hard enough to be stable, not to be degraded, not to be dissolved. In fact, well, not to be in the liquid form, and which are present on their own or as identifiable constituent particles in aggregates or agglomerates. Remember that I told you that nanomaterials have a high tendency to aggregate and agglomerate because of their high reactivity. In fact, and this is, let's say, a statement from the processing point of view, working with nanomaterials is very difficult because usually it's quite hard to keep the particles alone in the media because of this big tendency to aggregation, which are, and where 50% or more of these particles in the number-based size distribution fulfill at least one of the following conditions. And here it's important to let you know, we are referring to the number of particles, not to the concentration, not to the weight of particles. You can have a fraction of 0.5% of nanoparticles in a product, which can represent more than 50% of the particles which fulfill this definition. In fact, in theory, you can have one single particle which is very big and a very small fraction. So with very few particles, very few quantity in weight, you will have a very big proportion of nanoparticles in one material. So which are the conditions that are included in the definition? One is that one or more external dimension of the particle are in the size range of 1 nanometer to 100 nanometer. Take into account that we are talking about 3-dimension particles, so it means that we can have a very big flat particle, but if it's thinner than 100 nanometers, it will be considered a nanomaterial. The particle has an elongate shape, very elongate shape. We are talking here relating to rod fibers where two external dimensions are smaller than 1 nanometer. Remember that which usually we are referring to nanoparticles in the range of 1 to 100 nanometers, and here we're talking below 1 nanometer. And the other dimension is larger than 100 nanometers. This is for fibers, for elongated shape, and the following, the C, is referring to flat materials, okay, to plate-like shape materials. And here at the end, you have an additional comment in the last line that a material with a specific surface area by volume lower than 6 meters per square cubic centimeters shall not be considered a nanomaterial, because we have this other fact that the nanomaterials have a very big surface volume ratio. So this surface volume ratio is also an indication of what is inside in the side of nanomaterials and what is outside of the nanomaterial range. And here you have some, let's say, clarifications. What means a particle, which are single, and very important to know that single molecules are not considered particles, otherwise we will have nanoparticles all everywhere. What is understood as aggregate and agglomerate? Just very simple. Aggregate are very strong bonds, and agglomerate are weaker bonds. So it means that agglomerate will be easier to be separated in single particles. And then there is a recommendation to use the term nanomaterial in the different legislation and policy programs. So this is the current recommendation. And here you have which is the definition that was approved in 2011, which is similar, but you see that in this case, they didn't use the term solid particles. It was referred to containing two particles in general, which obviously included also liquids and some, let's say, emulsions. And the remaining definition is quite similar, but without that clarification, that the more complex clarifications that were added, as I explained it to you. So this is the definition used for nanomaterials, and here I am introducing to you the two guidance that are mainly used for the risk assessment and for the measurements of the products containing nanomaterials. The first is the guidance on risk assessment of nanomaterials in the food and feed chain. And the second is the guidance on technical requirements for regulated food and feed products applications to establish the presence of small particles, including nanoparticles. In fact, one very challenging thing when when we are referring to nanomaterials is to determine if the nanomaterials are present in the food. Because the analytical methods that can be used to determine if there is silver or there is silica in one food are not enough, obviously, because we have to determine the number of particles in the case of silver particles, but also the size distribution of these particles, which is a quite complicated task compared with, let's say, the traditional analytical methods. And here it tells you which is the flow chart for determining or for if the guidance for nanomaterials has to be applied to a product, or if it can be applied the guidance for conventional materials. So I'm not going to go through all these boxes. But as you see here, we have a decision tree. We have to answer different questions, and if the answer is yes, we go in one direction. If the answer is no, we go to the other. So here you can see an overall flow chart for the application of the guidance, and in this following slide, you have the whole picture of the flow chart. That basically consists in answering different questions just to know if the nanomaterial remains as nano during the process, and even if it's ingested as nano and remains as nanoform inside the intestinal tract, or as a contrary, if it's dissolved or it doesn't pass, for instance, from the packaging to the food, so there is no exposure to the nanomaterial from the consumer side. So here you have the whole picture. Obviously, it's just to show you an overall idea of how this works. And I prepared the last let's say flow chart in different blocks, where you have the boxes with the different potential answers, or in which direction you have to move depending on which is the consequence of your answer. I'm not going to go in detail on this because you have in the slices and it's quite easy to follow. Here you have a section related with the oral exposure assessment, the physicochemical characterization of the nanomaterial, and the risk characterization of the nanomaterial if you can't skip, let's say, the assessment, because the material is dissolved, because it doesn't enter in contact with the human beings, or because it's degraded during the digestion process. So this is referred to the risk assessment guidance. And with this slide, I finish the explanation regarding the scientific guidance for risk assessment of the nanomaterials. And as I told you, there is an additional guidance related to the establishment of the presence of small nanoparticles, including nanomaterials. Here in the screen, you have the decision process for selecting the applicable guidance document, which basically consists in determining if there is the presence of a nanofraction, which ends up in contact with the human body and can be absorbed by the human body. So, most of all, apart from the measurement of the dimension, it's good to know if there is if it is dissolved in different conditions, in physiological conditions, in which case it wouldn't be in the nanoform anymore, and it would skip from the scientific guidance for nanomaterials. So here you have the flow chart, and you can check it even to download the document, and you can read it with time. And now we reach to the last section of my presentation that deals with the application of nanomaterials in the food industry. Well, I have already explained what are nanomaterials. Here you can see an example of characteristics changing of a material depending on the size. Here you can see gold particles with different sizes, and how the solution of the particle, the color of the solution is changing depending on the size. In fact, one of the aims looking for nanomaterials is just to obtain a completely transparent solution, which can be used for different purposes, even to have some supplements in the diet. Well, we can skip this, and just when referring to the application of nanomaterials in the food industry, we have 4 different groups of application. One is the production and processing. The following is packaging and transportation, which most of the times are related among them. And finally, the distribution of the foods. And just to give a very important idea, the main application of nanomaterials in the food industry come through its application in food in the packaging to improve its characteristics, its barrier characteristics of, for instance, oxidative radical scavenging and things like that, or just to avoid the pass of the light or so on. And fortunately, in most of the cases, and in fact, this is one of the very important things in the evaluation of the safety of materials in contact with food, is the evaluation of the potential transfer of nanomaterials present in the packaging inside the food, so which will mean the potential contact of the consumers with the nanomaterials. And now I'm listing you some of the potential application. One is the production of nanoadditives and nanoingredients, which have some benefits, as in the case as indicated you, to have let's say a transparent solution, but also to increase bioavailability. In fact, one very interesting potential application will be the delivery of nanoparticles of iron, because you know that anemia is affecting a huge number of population, and it's not fully resolved the uptake of supplements with iron because of different difficulties or even pain in the stomach and so on. The nanomaterials or these nanoparticles can be obtained in the form of emulsions, which, as you saw in the definition, will fall out of the regulation because they are not solid particles, but can also be included in solid particles, such is the case of silica particles, which can even be porous. And then we can introduce inside the porous the different ingredients to be used or additives. Here you can see an example of what we have been working in our research group. We have been produced porous silica particles, which has been functionalized with molecules on the surface So they were used or can be used to introduce inside substances that have to be delivered in a very specific place and have to be protected in other places, or even during the processing of the food, but also during the ingestion. And then we can have the delivery on purpose in a very specific place of the intestinal tract. Here you can see that we have been working with these particles, and this is the curve of release when using the molecular gates for a controlled release of this of the substance inside of the particles. We have been working with folic acid. And in case of being free in the media, obviously there is an immediate availability of the body. And in this case, it's a problem because folic acid, the supplement of folic acid in food with a very fast absorption can have some health problems. Well, here there are some other applications. We have done this for the delivery.
Yeah, I think that you have to go to the conclusion just to leave some time for the questions.
Okay. Well, the other potential application is the development of antimicrobial reagents. The nanoparticles have been used, and this is another of the important applications. Well, here you have the slices, and you can check it when the presentation when you have more time. Another of the potential application is the enzyme immobilization on solid nanoparticles to improve the efficiency and the contact with the foods to be processed with enzymes. And as I mentioned to you, the other is nanopackaging, the addition of nanoparticles in packaging, which is very important to keep functionality, to improve the properties, and even to be used as nanosensors for determining the safety, the presence of microorganisms, potential pathogens, and some, let's say, possible toxicants of interest for the food industry. And with this, I will finish. Pier Sandro, I'm very sorry for this delay, and just available for any question.